All right, 810, describing relationship. So again, we're kind of talking about correlation. But we're being a little bit more, I don't know, maybe more specific. Um, we're going to talk, how does the data go? How does it go together? Um, it could be linear, it forms a line. It could be quadratic, it forms a parabola. Or exponential, it forms an exponential curve. Okay, lines, I think people are good on. I think I don't need to talk about those a whole lot. Parabolas and exponential curves probably need a little bit of talking. A parabola, it's something that looks like this, where you've got a little bit of like a swoop in it. It starts up high and it ends up high, or you could say, well, it starts down low and it ends low. So if you had data like that, you'd probably say, oh, well, that's going to be a quadratic, right? Because it has a little bit of a hump in it. It starts to go back up, or you could have one that looked like upside down version of that. You got like, and it starts to go back down. Okay. The big thing is that it curves and it changes direction, right? We could say with the quadratic, it changes direction. Okay. Exponentials, well, also, just by the way, quadratics, normally if we are modeling something in physics, like a rocket going off or something like that, you normally would use a quadratic, and you'd have some kind of graph that looks like this, and you'd have the rocket or whatever projectile you've got, and it would look like that. Just kind of to know what context in real life these could be used in. And like this would be like, what would that be? Distance from the ground. And this vertical could be time. Well, actually, the vertical could be distance from ground, and this would be like time in seconds or something like that. Exponentials. I mean, exponential, it curves, but it doesn't change direction. So if we're looking at it, the standard exponential is something like that. We could also have one that went more like that. But the big thing there is that it does not change direction. Okay. Just so we have this, I don't know that we'll need it at all. A linear is normally this y equals x. A quadratic is y equals x squared. And then an exponential might be like y equals 2 to the x. All right, a little bit different. Exponentials in real life, we've had a lot of exponential curves going around with the coronavirus, right? Because we could see like this would be time, and this would be number of cases. And as time goes on, it grows exponentially because people can share it to each other. And yeah, as it increases faster would be the way to say that. And for an exponential, as the exponential increases, it increases faster, which is kind of a neat thing to think about. All right, so let's get into this. Number two, we want to kind of categorize this as linear, quadratic, or exponential. So down here, we see there's a little bit of a curve in it. So it's probably not going to be linear. And we look at it and we're like, well, I could draw something like that in it. Okay. It has a curve and it actually changed direction. So this is going to be quadratic. Okay. Oh, also back up here, I used the word parabola. We're probably not going to need that word, but that curved shape is called a parabola. Just like how for a linear function, we have lines. For a quadratic function, we have parabolas. So they just have the fancy name in there, just two. Number three, I'm thinking that's going to be a line, so I'm going to say linear. Number four, well, what do we think this is? Let me double check and see what CUDA thinks it is, but I would say it is a line. What number is this? 4. Ah, they think this might be quadratic. So I guess I could kind of see that. We kind of come down to this and we go back up a little bit. We could call it quadratic, yeah. All right, number 5. Now if I start up here and I kind of swoop down with it, there's my turn. What do I want to say this is? Would this be exponential? Would this be quadratic? What do I think it is? Well, I'm going to erase my line for a second so that I can look at it. If we look really closely, this top bubble is above this one. So that says that it changed direction, so it's going to be quadratic. Right? The hardest part of this will probably be deciding whether or not it's going to be quadratic or exponential. Number 6. Again, we're going to be doing something like this. And it's going to be a quadratic. Number 7. Actually, you can see that it goes back up, so quadratic. So the big thing of this is that the quadratics are much more gradual also. We could talk about them being gradual in comparison to the exponentials. The last two are exponentials because we start here and it goes really fast down. And then number 9, we start at the bottom and it goes really fast up. So that's another way to see that, oh, this is going to be an exponential. If you see really, really fast growth, then it's probably going to be an exponential. All right, so there's that. Let's look back at a linear one. We've got the line, very standard, very easy. And then we have the quadratics. The quadratics have gradual change, and they change direction. That's the big thing. They change directions. And then exponentials do not change directions, and they change really fast. All right, that's all.